Hello, students. Getting into chapter 13, section 5, homework. Let's take a look at what we have. We have quite a few questions here because this is the section that honestly is probably the most challenging for everyone. So I've assigned additional questions so that you have more practice. We're going to go 1 to 2, 4 to 6, 9 to 10. All right, we start off with basic conversions. Remember, King Henry's dear mother drinks chocolate milk. If we're doing centimeters to meters, meters, cubic centimeters, all of those are going to be based on the same pieces. When you get down to the English system, the American system, try using those fractions. So let's do one together. Maybe we'll do the last one. We'll do part E here. So I've got cubic inches and I'm going into cubic feet. If I was going to be approaching that problem, I would just set it up with what I know. 1200 cubic inches. Next up, I want to get rid of inches. So I put inches on the bottom. I put feet on the top because that's what I want at the end. And I know 1 foot is 12 inches. Wrap my parentheses and cubit. At this point, the cubic inches go away, leaving me cubic feet. So I know I'm going to end with cubic feet. But I need to grab my calculator because I'm going to do 1200 times 12 cubed, but the 12 cubed is in the denominator. So if you want to write it all out and do it by hand, you can. This is times 1 over 12 cubed. Yes, there is a 12 in the top one because it's 12 times 100, and I'm dividing by 12 times 12 squared, and the 12s would go away. That would leave you 100 over 144. You could simplify that, but that's what your end result would be. You can get a decimal approximation if you need to, but I would probably leave it here, 100 over 144. What could I divide by? Looks like I divide by at least 4. So if I divide by 4, I get 25 here. If I divide by 4, I get 36. So there's my final result, 25/36 of 1 cubic foot. All right. Question 2, Jeremy's fish tank is 40 by 70. It's rectangularly based. The water is 25 centimeters deep. When he drops rocks into the tank, the water goes up by 2 centimeters. Remember, it's like 2 centimeters, but it's across the whole tank. So think about that volume as being the base, which is that area, times that height of 2 centimeters. And then you can convert that to the volume in liters. Remember, cubic centimeters, 1 cubic centimeter is the same as 1 milliliter. Okay, that would be my hint there. Always draw it out if you need to. 4 to 6 and 9 to 10. These are kind of just practice pieces, putting all sorts of different shapes together. The goal as you do it is to break down and find shapes that you know. If you know how to do a triangular prism, that would be this one, then build yourself a triangular prism first, find the volume of this top component, then take the volume of the other component and add them together. Some shapes are a little bit more basic, some are not. This one has a triangular prism, a triangular prism over here, a triangular prism over here, and then you could just take a standard rectangular prism in the middle. So you have 1, 2, 3, 4, and then the bottom piece would be 1 more of those, so 5 total. Again, just find each one, break it down, and then add those up. Oh, complete the following chart. So okay, so this one just looks a little bit different because it's vertical instead of horizontal. I had to look at it for a second because I was like, what did they do? But they made a change from when they were doing the books with me, obviously. Usually I saw A, B, C going down the side and then the pieces going across the top. And that's how my test questions tend to look. But it's fine. Let's see here. So take the easy ones first. Remember, 1 cubic centimeter is the same as 1 milliliter. So 200 cubic centimeters is 200 milliliters. 1200 milliliters is 1200 cubic centimeters, and vice versa. So that's kind of like a freebie. Okay. Now, milliliters to liters. King Henry's dear mother drinks chocolate milk, right? What is that? That's 3 spaces. So 3 spaces here would be 0.2. 3 spaces here would be 1.2. 3 spaces here, 0.202. And this one would be 6.5. And then 1 liter is the same as 1 cubic decimeter. So this becomes 0.2, 1.2, 0.202, and 6.5. So again, you get the idea. There's a lot of repetition in that table. Place a decimal point to the following to make them accurate. 20 centimeters times 10 centimeters times 10 centimeters would displace this many milliliters of water. You may need to add a decimal place is what they're saying. So when you look at this and you do 20 times 10 times 10, that would give you what? 2 and 3 zeros, right? That is what I should have for cubic centimeters. But remember, cubic centimeters is the same as a milliliter. So it should be 2,000. This says 20,000. So all you're going to do is say, I need to put a decimal point right here. That's it. And that's how you do question 6. All right, we're going to do 9, 10, and 13, 14. All right. So here we are. This is a rectangular prism with the given dimensions. You will notice occasionally they will give you some additional component down here. Your job is to find the missing measurement as well as all of the other components. Now, keep in mind what we did with the table above. The reason why I'm assigning this question is because we just did a table above that was fairly similar. 5 times 20 would be 100, times 10 would be 1,000. So this is 1,000 cubic centimeters. We know 1,000 cubic centimeters would be the same as 1,000 milliliters, which would be the same as 1 liter. And 1 liter is the same as 1 decimeter cubed. All right. Okay. Kind of shared that one. So I'm not going to go through each one of those parts. But again, if they give you something, use it would be my recommendation. Right? If they give you 12 cubic decimeters, guess what? I get 12 liters then, right? And if I have 12 liters, then that's the same as 12,000 cubic centimeters. Now be really careful as you read this table. The first one I did was all centimeters. The next one is centimeters, decimeters, decimeters. So either turn everything into centimeters or turn everything into decimeters as you're doing it to avoid any possible issues. Strong recommendation right there. Let's see here. I think these 9 and 10. Yeah. Okay. 2 spherical cantaloupes of the same kind are sold at fruit and vegetable stand. The circumference of one is 60. The other is 50. The larger melon is 1.5 times as expensive as the smaller. Which one's a better deal? Now, you could go in and find the volume of each one and say, I think the better deal is based on volume. That's fine. But also, if you're going to do problems like this, remember that if things are linear, then a scale factor of k is the same. If it's area, then it's k squared. If it's volume, then it's k cubed. And you have a ratio of a linear dimension right here. So if you want to do large over small and create that ratio, you could use that ratio to determine whether or not it makes sense that it should be 1.5 times as expensive. Does that make sense? Is the volume 1.5 times the smaller? All right, so there's 9, 10. We'll skip to the next page. Let's see here. What do we have here? 13, 14, and then 16, 18. All right, so 13, 14, determine the volume of silver needed to make the napkin ring. Oh, very interesting. Okay, now notice you do see some pieces in centimeters, and I will tell you something here if you're going to find volumes. My hint here is big minus small. I have said that many, many, many times, but if you find the volume of like the big outer ring and then the volume of the inner, because those are 2 cylinders, big minus small will tell you what's left over, and that would be the ring part. Very cool. Oh, theater. Shape of the popcorn. Notice, please make sure you read this part. The containers are the same height and the tops are the same size. So square here is the same as the square there. They're charging you half as much. Is it a deal? Is it a bargain? Which one do you get more for your money? Not more total, just more for your per dollar. Okay. 13, 14, done there. 16 to 18. Let's jump back. Oops, down here. One freezer measures this wide, sells for 350. Another measures this and sells for 400. Which is a better deal? All right, well, you don't need me for that one, probably. A heavy metal sphere with a radius 10 centimeters dropped into a right circular cylinder. If the original cylinder has water that is 20 centimeters high, how high is the water after the sphere is placed into it? So take a moment. The heavy metal sphere is going to sink to the bottom, and it's going to displace that volume. What is the volume of that metal sphere? And turn that into, let's say, cubic centimeters. And then see how high is it going to go up, because that volume should go up overall. And again, you're dealing with a right circular cylinder. So remember, the right circular cylinder, the volume is the area of the base times the height. And so when you have something like this, if you drop a ball into it and the water level was here, the water level is going to go up a little bit to mark this new piece because you just put a ball into it. And so what you want to do is say, well, what's the area of that base times the height that would give me that volume that I'm looking at? And that's how you can find how much the water went up. I wish they did one of these with the rain barrels. My friend bought a rain barrel. Maybe I'll have that question on the test. There we go. A box contains a can. What percentage of the volume of the box does the can occupy? Huge hint. Turn this sideways and it looks like a circle inside of a square. And if you do something along those lines, you might be able to find that because the height of these is the same. So it turns out to be a very similar question to what we did earlier with squares inside of circles and circles inside of squares. 22 to 24. Let's see here. For each of the following, choose the correct unit. A dime has a mass of milligrams, grams, or kilograms. Now remember, a kilogram, we talked about this, a kilogram is about 2.2 pounds. Okay. Okay. So does that make a lot of sense? How much would a dime weigh in terms of grams, milligrams, or kilograms? A big hint, probably not kilograms. Let's see here. A recipe said to add 4 how much of salt? Okay. Is it going to be a gram of salt? Is it going to be a milligram of salt or a kilogram of salt? A kilogram of salt. Yeah, recipe says add 8 or 9 pounds of salt. I don't think so. And one strand of hair has a mass of blank. So again, if you're making a recipe, typically that would be for a larger amount. 4 grams of salt may sound like a lot because we measure typically a certain number of milligrams of salt. But if you're making a recipe that is going to serve a number of people, then that is distributed throughout. So it's not like you're just eating 4 grams of salt. Complete the following conversions. This is kilograms into tons. Okay. And don't forget here, 1 pound is 16 ounces. So again, I think that could be fairly helpful for you as you go forward. And yes, that is one that I would put on an exam. I would give you 16 ounces is 1 pound. I'm not asking you to memorize that one. And let's see, a paperclip has a mass of 1 gram. Is it possible to lift 1,000 paper clips? What about 100,000 paper clips? So that great question. Great question. And that takes us through 24. Last is 27, 28. The weight of $1,000 bill. Wow, $1,000 bill. Turns out, I think in America, the weight of any of our bills is about 1 gram. Okay. So that gives you an idea. Okay, that's like a $1 bill, a $5 bill, $100 bill. Those are all 1 gram. How many $1,000 bills are there in 1 pound? So now take your grams. You can turn your grams into kilograms, kilograms into pounds, and vice versa. But this is a question I do enjoy asking. I love watching movies where someone is like asking for a ransom and they say, yeah, give me, $10 million, but I want it in small bills, like $5 bills. Okay, how much does that weigh? Right? How much does that weigh? And can this person just lift it up like they're just lifting it up and walking around like it's no big deal? That's always a good question to ask. All right, 27, 28. Let's see here. Oh, this is just converting pounds into kilograms. Okay. So again, we're going to use 2.2046. So that's and I'll put that on the test as well. I'm not asking you to memorize it. So 1 kilogram is 2.2046 pounds. All right. And let's see here. And what was the last one? I think I had one more on there, didn't I? Homework set 31. Question 31. Okay, recipe calls for 0.25 kilograms of chicken per person. You bought the chicken in pounds. Well, how much chicken is needed for 5 people? Huh. Well, take your kilogram to pound ratio. If it's a kilogram of chicken per person, you need 5 people, multiply 5 times 0.25 kilograms. That tells you how many kilograms of chicken you need, and then turn that into pounds over here. As a quick rule of thumb, if you were just like really, really, really getting estimatey on this, then what you could, I'm going to estimate. I'm asking you to actually calculate, but if I was going to estimate, 1 kilogram is about 2 pounds. I know it's 2.2, but I'm going to call it about 2. And that way, if somebody says, okay, well, then how much is a quarter of a kilogram? Well, then it's a quarter of 2 pounds, which is about half of a pound. And that's pretty typical. If you do any catering or if you buy large amounts of food, because I have to do some event pieces, it usually is something along the lines of it's about a half a pound per person that you end up serving. Like if you're getting a turkey for Thanksgiving, how much is it? Well, it's about a half pound per person. Okay. Yep. But there you go. That's a reasonable rule of thumb, half pound. Again, half pound in our system is 8 ounces. And when you go out to restaurants and you order, like a steak or something along those lines, a steak usually is sold about 8 ounces, which would be a half-pound steak. Let's see here. If you go to McDonald's and you get like a quarter pounder, obviously that would be 4 ounces, a quarter of a pound. But if you get the double quarter pounder, then that would be a half pound, which would be 8 ounces of beef pre-cooking, I should say it that way, before they cook it. And I did used to work there. And what's interesting is they never called them quarter pounders because quarter pounder is a lot. They called them 4-to-1. And 4-to-1 tells you there's 4 of these for 1 pound. But hey, grab me some 4-to-1. That's so much quicker than saying, grab me some quarter pounder patties. It's just too long. And if you're at McDonald's, you need to go very quick. If you're thinking, hey, how about those other hamburgers, Scott? The smaller ones, how big are they? Those were called 10-to-1, which lets you know that they are a tenth of a pound each. So there you go. Fantastic. I love weird, wacky facts to end this video with. Clearly, I'm in a good mood, still recovering from whatever is never going away. I've had like this cough since March and it's just never going away. So I hope that you're feeling better if you were feeling down, and I'll see you shortly. If you have other questions, please let me know. I can make additional videos, and I look forward to seeing you soon. Off you go.